There we go. The annoying browser window's gone. Okay, so obviously we're all here for a reason, right? And we all know that VR is on the verge. It's on the verge of kind of coming into the consumer market, but it's sooner than you think. Because I think a lot of you already know that in the States right now, for the very first time, you can get Google Cardboard at Best Buy. That means that we have crossed the line into consumer VR, and we're at the dawn of a completely new era in terms of what's going to be available to us. So 2016 is a really big year. 2016, there is going to be 5 VR platforms from major companies, and these aren't the small guys either. I'm sure that other people have talked about this, but I'm just going to go through and just make sure that we're clear about this. We've got Sony, we've got Valve, we've got Facebook with Oculus, we have Samsung, and we have Google. If you think about that, like Google and Sony and Oculus, all these companies are some of the biggest companies in the industry, and they have products that are either out today, like Google Cardboard and the Samsung Gear, or they have some very high-end products that are coming out next year. So that's a huge deal, to go from virtual reality being something that is barely talked about to it being something that is going to be in stores from these major companies is a major, major, major line to cross in terms of it being a very valid medium. So, what works well in VR? That's a good question. I'm going to talk about, just before I get into that, I'm just going to talk about VR. A lot of the things that we're going to talk about, that I'm going to talk about today, a lot of these user experience like kind of strategies, what you'll find is that they will work in AR in the future. And over time, I think that you'll see the industry will kind of start to converge a little bit moving forward. So maybe 10 years from now, we'll think, right now they're completely separate, but maybe 10 years from now, we'll start to think of them as almost the same thing. It's kind of a slider of how much reality is there and how much you're just projecting the virtual experience. So what's changed? What's changed from 3 years ago or 5 years ago or 10 years ago today? So the big thing that's changed is how well we can do VR. So what that means is we can do a really wide field of view. We can do it really fast. So you turn your head within anywhere from 60 milliseconds to 30 milliseconds to 10 milliseconds maybe in a couple of years. That display is being updated. So that's good enough, or better than good enough, to completely fool your visual cortex. Also, if you look at VR in the past, everything was proprietary. Everyone was inventing everything, including the tools. The market for 3D interactive tools was not that strong. Everyone kind of invented their own game engine or their own 3D engine. A lot of people who were doing VR systems, they would have their own tools, and it was very, very difficult to learn. Now there's a ton of people out in the industry who have the skill set already. If someone has worked potentially in film, or they've worked doing 3D games, you have the right skills. You already have the right skills, and those tools are actually a lot easier to use. So even if you don't, it's something that's very obtainable for creative content creators. Okay, so now let's talk about what works in VR. I'm going to just show you a video of a project that I've been working on over the last year, because I'm going to use it as an example of some huge failures that I've had and some huge successes as I kind of go through the talk. Never use the internet in a presentation. Okay, let me just try one more thing here. Oh, it looks like it almost worked. Let's try one more time. Okay, I think I've got a local copy here, so I'm just going to pull that up. This is a game called Fist of Fire. It uses a lot of rules that are good for user experience design in VR, and it breaks a lot of them, and there's a lot of lessons that you can be learned there. So the premise of the game is that you're shooting fireballs at enemies, and you have to dodge incoming attacks, and there's a lot of things that I do to kind of maximize this experience in VR. So you get a good idea. You shoot fireballs, you're in space, there's a number of things that kind of help you along the way. Okay, so what works well in VR? One of the most, actually the single number one most important thing in VR is presence. And I know you've heard a lot of people talk about that. And this kind of goes back to what's changed in VR. And essentially what it means is we're able to fool the visual cortex at a level where you get full buy-in that you're in a virtual world. Now there's certain constraints where that works and where that doesn't work. But this is what VR does that no other medium has ever done. And so every VR experience that you have, it is always going to be the most important thing in every single VR experience. Sight. So we've created a world. You can turn all the way around you. There is a 360 environment. It's completely 3D. It's believable. Visual exploration, you have to have a lot of visual exploration in your work because we've put you in a world you believe you're there, and you just have to take advantage of that in virtuality. Users need to want to look around the world. So now that we've kind of taken you and we've transported you into a different dimension, there's a new kind of a standard in terms of the aesthetic or the feeling that you need to create within that world. So you want to have a lot of things that really encourage the users in different ways to feel like they're there and to feel like they want to look around and explore that world. Things that are close. Now, so because we're doing this all in 3D, this is no longer you're looking at a screen. The way that 3D inherently works is the closer something is to you, the more you feel you can touch it. So if there's something and it's 50 meters from you, it's not very 3D. If something, like if you take your finger and you kind of go to your eye to poke yourself in the eye, it feels very 3D. And this kind of rule of thumb works well within virtuality. And you kind of need to think about that in terms of what's important. So what's important from an interactive perspective, what's important from a visual perspective, there is a higher value for things that are closer. And so that's something that you need to really incorporate into your designs and user experiences. Exactly. I totally agree with that guy. In FITC of Fire, one of the things that I do, I incorporate depth in a lot of ways and volume. One of them is there's projectiles that come at you. To make those feel imposing, I always shoot them directly at your eye. Because and I actually, in this game, at some point, I did some prototyping. I was just shooting cubes. Then I moved to Fire. Fire wasn't imposing enough, didn't feel like something was going to hit me in the eye, so I had to add some stones to it to really add a lot of value. That forces you to look around and it forces you to engage in the world. The other thing that I do in FITC of Fire is the scene. I've really worked hard to lay out the environment so that there's always a lot of multitude layers of depth. So when you're standing on a pillar, you look down, you see that there's a huge drop. That vertigo is something that conveys really well in virtual reality, so it makes you feel that there's a lot of weight to the experience. Just really simple things, like I have a lot of volumetric aspects, there's a lot of particles, there's a lot of things that blow in your face. That also adds to that sense of depth. The enemies and the projectiles and everything else, and the fact that I've incorporated your hands, this also helps anchor you into the virtual world, and it adds a lot of value and a lot of weight to the entire world itself. And so actually one of the problems I have with this game is if I put the headset on, there's a percentage of users who don't want to play the game. They're more interested in looking at the world. So it's a good problem to have, but it's also just something to be aware of. So I'm going to show you, I'm just going to try and grab 2 seconds from this clip. It's probably not going to work because, the internet's not my friend in this presentation. Well, we'll see what happens. Looks like it's not happening. Okay, well, what I was going to show you is just, this is one of my favorite examples of showing VR and showing the power of presence in VR, the fact that you feel that it's a believable world, you feel that you can touch things in this world. And actually one of the first things that people do, it's rebuffering my thing. One of the first things you do when you try VR for the first time is you reach out and you try and touch things. So the example I was going to show is a horror experience, and one of the things that you'll see universally, like when people try horror games in virtual reality, is there's a universal response where it gets really scary, and people take off the headset, and they say, no, 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 and they put it down, and they can't handle the experience anymore. So for whatever reason, this works. Okay, let's try this. Okay, that's fine. I'm just going to do it from this view because this works. Okay, so let's talk about what doesn't work in VR, because this is actually a really important thing to understand. I mean, there's a lot of talk, if you think about VR in the 90s, you know, a lot of people talked about nausea. It's still an issue today, and there's definitely things that you need to not do, and you need to understand why you can't do these things. And this image kind of, it simultaneously shows you pretty much everything that you shouldn't do. So gravity is really important. Sight is really important. These are two things that tell us like how we exist in the world. So we've done such an amazing job at taking your visual cortex and making a believable visual experience where you feel that you can reach out and touch things. The problem is your inner ear is equally powerful as your visual cortex. And you don't really realize this because you don't just think about it. It's just something that puts you in the world. So it tells you, you know, what the horizon line is, you know, kind of how gravity works. Also tells you when you start to move. So if you move in virtual space, someone starts twisting you, you know, you're in a car, you hit a wall, all these things, they don't match up with your visual cortex. And so what happens is in the wild, if those senses don't line up, it probably means that you've eaten some kind of like toxic mushroom or something like that. And we have a very natural response to that. The body says, well, you've probably eaten something poisonous, so we're gonna make you vomit. And so that's where a lot of the feeling of nausea comes from. So kind of understanding what causes nausea, like artificially moving the player when they don't feel that in their body, that will cause nausea. There's lots of things. You really need to incorporate that into your design approach. But you're going to break the rules sometimes, because sometimes you want to do a creative experience, and you know, maybe you're going to break the rules for a small period of time. Maybe you're going to break the rules a lot. So I have another thing that's not going to work. Let's just try this. Okay, let's see if I got a local copy of this. Hold on, bear with me 1 second here. Yeah, Wi-Fi was working better before. No, you're not indexing either. Sorry guys, it's my fault. I should never ever do Google presentations. Sure. Okay, let's try this one more time. That sounds good. Oh, look at that. Give a round of applause to the person who gave me the obvious answer. Thank you. Okay, so this is another example of maybe some things that you could do, but you shouldn't do, and I'm going to explain like how I minimized those things that you're not supposed to do to create what I felt like was a workable experience. This is a first-person. So basically, one of the things that doesn't work in VR is kind of first-person shooter mechanics, and so I, you know, kind of went out of my way to break the mold and create a first-person shooter mechanic that I felt worked in VR. And so what I'm doing is, you can see that I'm rotating in the real world. So what I'm doing is I'm taking every action that I can do in the real world, I'm doing in the real world. And then one of the biggest no-nos that you can have in VR is velocity. So when you accelerate really quickly, when you change speed and direction, that is something that causes nausea. So what I've done here is I have a very slow level of acceleration, and then I'm mapping a whole bunch of the user experience into the real world so that you still feel like maybe 80% of what you're feeling through gravity, and then there's a gentle push, which is quite bearable, and I haven't had people tell me that they feel nauseous from this. I've spent a lot of time working on this experience as well. And what it does, by breaking the rules, what you get, and there's some other examples out there, some people have some very different ideas how to handle this, but what it does is it lets you freely explore the world. And I find that once you're in virtual reality, the first thing you do, you see these horizons, you see like these long distances, is you want to kind of get out in the world. There are other techniques that are coming out that are interesting. It's a tough problem. Everyone is kind of trying to solve it right now. We'll see what the right one is. Another example is Bullet Train. They have a teleportation technique. You can kind of just point at things. You can teleport there. There's some new techniques where what people are doing is they're limiting your field of view. So if you think about it, when you look at a 3D TV or a normal TV, you're fine. And part of that is because when it goes really wide, you feel like it's real. When it's a smaller window, it starts to feel like something that you can accept. So there's a whole bunch of ways that people are trying to get around the issues of what doesn't work in VR, and it's just something that you need to be aware of. So we've got a whole new range of input possibilities that are coming out on the market, and the types of designs that you can create for these input experiences are radically different. So I mean, when the Oculus first came out, people were mouse and keyboard. Then they've moved to the gamepad. The new Oculus, the consumer launch of the Oculus Rift is actually going to come with an Xbox One controller. It does a lot of things well because there's not a lot of interpretation. You've got the Gear VR. It has a touch controller built in as well, and it also works with gamepads. Then you have some of the more ambitious approaches, which is to do some level of hand tracking, which is what I'm doing in my Fireball game. And then you have controllers from Valve and Oculus, where they're doing essentially the equivalent of a gamepad plus hand tracking. So it gives you the precision of button presses, so you don't have to deal with gestures, because gestures are an issue onto themselves. But it also gives you the ability to reach out and touch something, to point at something, to interact with the world in a more precise way. And so there's a spectrum of these devices that are out there, and you need to start thinking about how your experiences will scale and how they will map to all these different devices. So user intention, that's how you're going to map across all these different types of experiences. Whether you're using just a headset, or which would be like Google Cardboard, or a headset and a button, or a touchpad, or whether it's a gamepad. What you're trying to do is you're trying to map the user's intention into the world, and so you have to start thinking about how that's going to happen. If you think about traditional user interface design, I mean, we're all familiar with the mouse cursor. This is one of the first things that we've kind of familiarized ourselves with in terms of how to interact with a computer. That was a little bit more intuitive. There's a lot of the same things that happen. In virtual reality, though, I mean, how do we actually express, how do we actually interact with the real world? Well, we use, in an ideal way, we use basically our sight, our senses on our head, and we use our hands to interact with the world. And a lot of this maps across that spectrum of input devices. So the easiest one, the most reliable one that you're going to find in every single VR solution is where the user's looking. And there's multiple ways for you to kind of map that intention. So one is you can use a traditional user interface, and you can map that selection into a traditional user interface. That traditional interface can be in 3 dimensions. You can show highlight. There's all kinds of things. But what you'll find is from Google Cardboard to the Gear to Oculus to all these platforms, you always know where the user is going to look. And so that's something that you should think about in terms of a way to drive your interactions. Every time you look at something, if you're doing this type of interaction, you always need to give the user feedback. Now, when it comes to more complex mechanisms, there's a lot of interesting issues that come up. And there's some companies that have some really interesting approach. But one of the things you're going to find is the only thing that you can show is you can only show what's right. So, for example, I know there's a plethora of people that have different opinions on this, but for example, if you don't know where the user's elbow is, you don't know where their shoulder is, you don't know where all this stuff is, the best thing to do is to get rid of it. Because what you'll find in virtual reality is you only focus on what's right. And in the real world, when you're talking or you're doing tasks, you're not actually thinking about your elbow or your shoulder or all these things. You're thinking about your hand. When you're talking, you're moving your head. You're also, once you pick up an object, you're thinking about the object, and you're no longer thinking about your hands. And so what happens is, and this is a great example, this is a game called Job Simulator. One of the things they do is they have this idea, and they really want to make it a thing, so I'm going to use the term that they use, which is called tomato presence. And what that means is, in their game, what happens is it was originally designed for Vive controllers, so they don't know the position of your fingers, so they just show the equivalent of mouse cursors for where your hands are. When you go to pick up that tomato, your hand disappears. Okay? Doesn't seem like a big deal, but what's happened is I've transferred my focus and my intention from my hand, because I'm moving my hand because I want to interact with something, to the object that I'm interacting with. How this where this really gets interesting is when you start dealing with errors. So, for example, if I see my hand and it's not in exactly the right position, and I'm holding this tomato, my brain's starting to like disagree with it. If I take my hand and I whack it through the table, that's a problematic scenario. So how do you deal with that from a user experience design perspective? Well, they come up with an interesting solution. You pick up the tomato, your hand disappears. The tomato always obeys the rules of the virtual world, but of the real world as well. So if you take that tomato and you take your hand and you smack it through the table, what happens is the tomato bounces on top of the table, your hand reappears, and it's a scenario where you can understand that your hand is essentially your input device into that world, and you can transfer it, but once it stops working and it becomes a wrong scenario, it resets back to you, to the item behaving as it should, and your hand reappearing so that you can re-engage with that item. And then I'll show this, but I'll just show a little sample of this because it's kind of cute. You will see them when they pick it up, item disappears. And when you're actually doing, and you'll see like he'll throw it in the air, he does all kinds of things. So you need the hand, you don't need the hand. You need the hand, you don't need the hand. Right? There's actually a lot of interactions that are going on here, right? And they're actually happening like fairly intuitively, right? So they've done an excellent job of helping like kind of define a way for this interaction to happen. Yeah, you guys really like this one, eh? So big props to those guys for really helping define a really good way to handle that problem, but it really highlights what happens, right? You need to map that user intent. Now what happens is I don't know who's seen the Toy Box demo. I was in LA and I did the Toy Box demo, and one of the things that you notice right away is when the head moves and the hand moves and that other person is a real person and they're talking to you, you can almost kind of tell what that kind of person was. Like you like, I know I'm talking to a girl, I bet you she's short and she seems like she's probably cute. She came and talked to me afterwards, totally right. But the cool thing is the reason this works, and I've done other like VR chat systems and avatar systems, and the ones that have full body and it's very detailed, and it doesn't react in the way that it should, your brain kind of finds that offensive because it doesn't work. But what happens is when you have an abstract representation and the only things that you're showing are correct, your brain is very, 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 very happy to fill in those gaps. So in this example, the visor kind of bobs from the head tracking of that user. And so as they're talking, you hear the voice in real time and you see the head bobbing. You see the hands moving, just like really like small gestures. All these things translate really, 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 really well into a social experience. So that same kind of process that you would go to map user intent also applies to a social experience, and it's incredibly valuable. So I'll just show you like a quick video now that YouTube's working again. Just them talking, them chatting. It's not nearly as powerful as actually being there, but this is a very, very powerful thing. And there's Samsung has on the Gear, there's a new thing called Oculus Social. They can only track the head bobbing, but just seeing a head kind of like rotate and like look around and seeing the amplitude of sound coming out of a smiley face, you're totally willing to buy into that. If it was some weird kind of like lip syncing that didn't work and a bunch of other things and it was too descriptive, you would not buy into that. And that's a lot of people have talked about the uncanny valley. It plays a big factor in VR in terms of having a positive interaction. There's some older research that people were doing, or older input systems, and they would try and like have a rig, and they would do IK on the arms, but when it doesn't line up, that is massively problematic. So what about user interfaces? Well, user interfaces are interesting. If you think about a typical game or a typical app, there's something, and it's just kind of always there. In VR, you need to start thinking about where you're going to put it, because you can't put it on your face. If you have something anchored to the face, you'll turn into something, they'll have a depth collision. There's That's not how you want to exist. You don't want to have things attached to your face in the real world, and you don't want to have it attached in the virtual world. So you need to start thinking about, well, where can I put that? So if it's something like a very general menu, you can kind of know approximately where it would be in front of the user and give them that context. If it's an environment where the user can explore, job simulator is a great example. Kind of mapping traditional UIs is a great example. You can make a physical device in that world. The other thing you can do is, if you have like hand tracking, is you can put things in people's hands. So if you think of it as like the metaphor of, I have a smartphone in the virtual world, it can display information. So I can look at that when I need that information. I can call menus up. There's a number of different ways to handle that, but you really do need to think about, where am I going to put these things in virtual space. Okay, so this is something that I failed at many, many times, and so I just thought I would share it with you. And this kind of applies to like a lot of targeting systems or like traditional HUDs. The depth becomes a really challenging thing. So what happens is, for example, if you do the old like this, and you look through it and you don't close one of your eyes, and you're trying to like kind of frame something, what you'll see that your fingers double. You'll see 4 fingers. This happens in VR. So if you're trying to provide contextual information, you need to think about, what's the depth that information needs to happen at. So this was a system where I tried a whole bunch of things. One of the things that I tried was, I had like a little power meter. It showed you, how much you were charging your fireball. I had a little circle, just my early prototypes, show you where you were aiming. Both those things failed. So even when I took the, in a later version, I thought, I'll make it more subtle. Still double vision, wasn't working. Eventually, I just made it into a line, made it very literal. But what happens is you can look down the line to the thing that you're trying to target on, and so you can focus on what makes sense. I made the line so that it gets more red as the power builds up. It's not the best solution, but it's one that's contextually correct for the depth. So a lot of times, like, what you'll have to do is, like, if you want to display information about an item, you may have to put it on that item, or you may have to put it within context of that item. But the depth and user interface design is something that you would never think about in Photoshop, but in a real world space or in a virtual space, it is crazy critical, because it will create either a very natural experience or a very unnatural experience. Another example would be, like, just if you're doing a first-person shooter, you may have to have multiple copies of your targeting system so that the player can look down at it, and that's a little bit like what I was doing. The other thing I'm going to talk about is just interactions. So, we all kind of remember the Wii. We've all, played Kinect games, and one of the things that happens is conceptually, this is a fantastic idea. I can be a real world in a real space, but gestures suck. They don't suck, but they do suck, and there's a reason that they suck. One of them, the reasons that they suck is, as a computer, like when you're designing an interactive system, what you need to do is you need to look for something. You need to look for a very specific type of behavior. The problem is in the real world, there are a magnitude of right ways to do the same thing. Computers don't like looking for a magnitude of the right ways to do the right thing. That's a very confusing thing for a computer to understand. They want a condition where something becomes true. So if your user interaction is too complex, you're conveying the wrong information, because there's too many possible ways for your user to fail. What does that mean? It means it needs to be like incredibly obvious, incredibly reliable. And the example I would use is if you think of old adventure games. You find the key, you put it in front of the keyhole, it does the thing. And that's a little bit of what you want to do. And it kind of comes back to what I was talking about earlier with mapping user intention. So it's the same kind of idea. If you are doing something and you're getting it close to something, or if you're combining things in a certain way, or you're making or if I give you like really simple choices to make, I just want to make it so that you don't have to do exactly that, but you can pick the thing up and you can trigger the interaction, and you have the user choice. I want to make it so it's simplified, so there's no wrong way for you to do it, but I want to give you the power to make those choices. So automation. Automation is a big part of this process. I break these rules. I don't always follow them, but that's definitely like an important factor. So the other thing to think about is, like, how do I take this simplification and kind of span all these devices? Well, honestly, like, you're not going to get more simple than button presses. So the hardware that has that, you're going to do that. Other devices, you're going to have to simplify the user interactions. So maybe it's a gaze-based look. I look at it for a certain amount of time. I trigger interactions. But you really need to think about the hardware that you're going to be designing for. You need to design your UX so that it's simple, reliable, and that it always works for that type of hardware. Thinking about user intent, there are creative ways that you can take those same experiences and map them across different hardware, but it will be a different experience. So no wee waggle, right? If you can create a more direct experience where there's no gesture, you're just aiming, and like bullet train's a good example of that. You can just interact with the world like you would, whether you're pointing and looking at things, and the interaction is much more obvious. It's a much more real interaction. If you can avoid a wee waggle, that's definitely a good time. The other thing you can do is, if you have something that's a little bit complex, is you can create really obnoxious user interface elements to reinforce that behavior. So if you think of games, this happens all the time. You have to put things into the world that tell the user exactly what's going to happen with that behavior. So for example, one thing that does not work well in games and it does not work well in virtual reality usually is throwing things. It's really hard to predict exactly when you're releasing things, the timing's right. If you're going to simulate that, just show people like what's going to happen. Like show as much as possible about what's going to happen in the virtual space so that they have control over that interaction, so that they're making a choice as opposed to screwing up. My advice is basically to fail. It's to test, rebuild, improve, learn. Don't get too obsessed with art. I mean, it is good to have really great art in your work, but when you're figuring out what your core interaction system is, to take a step back, maybe do some gray boxing, which means don't invest heavily in art. Don't invest heavily in art. Invest in the user experience. So make it work. Add art. Once you've got it working, add it. Make it beautiful. Create the environment. Add the value. And really like deliver a wonderful experience to the user, but just make sure that you're moving quickly, because there is a learning curve, because everybody's figuring stuff out, right? This hasn't been around for 10 or 15 years in terms of general audience. So most designers, most companies, big, small, everyone's figuring it out. I guess one of the last things I'm going to talk about is so we're all here because we want to connect or we want to learn. We want to help develop our skills. I run a group called Toronto VR. So we're a monthly meetup. We're around 800 plus members. We have really great talks. It's a fantastic place for you to collaborate. So if you're an artist and you want to meet a developer, vice versa, if you're a filmmaker, you want to meet someone who can help you, do some VR film stuff. It's a great collaboration space, and I highly recommend that people sign up, because there's actually been really interesting projects that have come out of the group. So you may have an idea and someone may be able to help facilitate it, or vice versa. You have some skills and you hear someone's idea and you really want to collaborate with them. So I guess that's it. And I'd like to thank everyone for coming out, and give me a round of applause if you want. It's good.